So this is the system running here now, and it's generating electricity at the minute. I'll just show you how much now in a second. Spinning right, it's running well. There's reasonably good wind there today. I'm concerned about a vibration on the back of the fin, the tail in the back, but I think it's got to do with these trees here, so I might get them cut back. And it causes a tiny little wobble. You mightn't see it there, but that would be detrimental to the mechanics of the system itself. Right, so you can see here from the meter just inside the door, we have 242, 240 watts, volts, 11 amps. It's at 24. 24 is a standby, and it's 159 units generated. They're all pretty much this month. Last month there was very little wind, so most of that is this month. So now you can see it's kicked in, so there's a half kilowatt, third a kilowatt. So it fluctuates up and down quite quickly depending, and now it's back in standby. And that's depending on the, obviously the strength of the wind. Okay, so this here is the control panel. That panel there, it's in the actual inverter cabinet itself. You see it's in a fireproof seal. That actually shows the revolutions at the minute. So that's the revolutions of the actual blades, right? It normally kicks off at 65, but it has kicked off because after a while it only kicks off at a higher rate if the wind is quite high, and it's reasonably high today. And it kicks out then around 45, 40. So this here, when it flickers, it represents the actual, tells you that there's revolutions in the actual blade. So it actually causes that to either fluctuate up or down. So it's at 0.1 there now. And you can see why, because it's just almost at a standstill there. Okay, so only one revolution. So it'll kick up again because I know it's kind of breezy on and off today. It's about a half minute later now. You can see it's back up spinning again, and just come back into the inverter controller box. You can see here now that the power transfer button is on. If there's ever an over voltage or an under voltage or a frequency differential out of the spec, it'll immediately stop, and it'll indicate which one is the issue. You can see there that when the rotation went down, the power transfer went off. When there is power transfer, there's power being generated. There's back up again. Now looking at the form that needs to be completed, if we just look here, you can see here that there are under over voltage, under over frequency settings that just needs to be confirmed, and these settings are represented up here. Okay, so you have the over under frequency here and over under voltage here, and all it's asking is to check this application is asking to check and confirm that the settings have been applied. Okay, it has been running steady for the last it's 2.5 weeks now since it's been up and running, and it's been running really steady. So we're looking at the cabling. The cabling that was done was, this here is underneath is called a choke, and this choke sends 4 cables, and it acts as a huge capacitor to smooth the ripple on the AC voltage coming in. So looking at the AC voltage, you can see here that there are 2 trip switches here, or 2 switches, and this larger one is for the wild AC coming in, and it comes in between I think it's each of the 3 phases brings in about 125 volts each. Okay, so they come in here. I can knock that on and off here, which is what's asked of. It's brought down and then into the controller box, and then behind this control panel it's actually connected to 3 junctions, which in turn feeds the regulator, which is what's up there in the top left. The top right is, we didn't have to touch that at all. It's the starter panel, and it worked perfectly. This here is an important box. It's the G59 box, and what it does is when you power up, I'll just look at the other switch here for a second. When both of those are on, one is coming from the turbine and the other one is coming from the mains, the actual mains up to the fuse box. And it's connected in here first, and that's the first box I checked. And if your friend needs a check on that, what I can do is I can actually run it here online and demonstrate it working. And the idea behind that box is if there's a power cut on the grid, that this kicks in and it automatically stops any power going from the controller into the actual into the mains, and then inadvertently going out to the grid, which is a no-no. So that's the most important box of all for safety reasons. So then you'll notice here that there's a cable coming out here separate to the AC, the wild AC, and it's going out to the it's going out to the actual turbine. And in behind here there is a DC supply, and it's a DC voltage. It's sent out to an exciter winding underneath the main winding. And the DC voltage, the idea behind that is the higher the voltage, okay, the higher the wind, increases the DC voltage, and then in turn what it does is it increases the magnetism of the actual main winding to produce more AC, wild AC, which then in turn that three-phase comes in here and back in here, and then eventually fed into the mains, and then eventually fed out to the grid if only surplus is sent out to the grid, is pushed out to the grid. So I always keep this under lock and key just in case any children inadvertently open it. Okay, so that's the inverter controller unit, and you can see at the moment there's 60 revolutions on the blades, and that's high enough to create a power transfer which is generating electricity. Now we'll go into the actual fuse box here. So you can see there it's working quite well at the moment. And as I said to you, there is it produced a little over half kilowatt, 3/4, and it goes up and down quite quickly. There's over 1 kilowatt. So that there is, and it's the voltage and the ampage. Okay, and then the bottom one is the amount of units accumulated over time. So just to show you the complete loop, any surplus is fed then into the grid, and that's, I don't know if you see it on the screen there, but that's A minus, which is the mode to show the amount of units fed back into the actual grid itself. And at the moment, I don't know if you see it there because I know it's dark, it's at 73. You can see it there at 73. So just to reiterate, what I'm looking for is hopefully find somebody that would sign off on the work. They can either inspect the work, they're welcome to come down and have a look. It was done by a qualified electrician. And then I sign off on this. We can do it remotely. I can do a video to test the G59 unit, which is the important one. Even though it's not asking for the test here on this, all it's asking is to verify that these settings were put in place against the unit that I showed you earlier on, and that's over voltage, under voltage, and under and over frequency. As I say, it has been very, very stable now for the last 3 weeks, so I'm hoping that it'll continue to do so. And I showed you the entire flow from start to finish. The cabling is, as you can see, it's quite neat. It's very, very well finished, and as I say, in working order. Everything is working perfect on it. So I'd pay the individual premium rate, whatever his going rate or her going rate is. Thanks very much, Dave.